Good day, everyone. I'm Falullah Giwa by name, and here I have my colleagues Zainab Raji and Suleiman Muhammad. We are the group 23 members of set 313, which title goes by Information and Communication Technology. Our topic for today is Science Development 1, and our learning outcomes. By the end of this lesson, students should be able to 1. Explain gravitation and weightlessness. 2. Describe the Earth in space. 3. Identify the components of the solar energy. And 4. Explain the rotation and revolution of the Earth and the Moon.
Good day everyone, I am Zainab Raji by name and I will be explaining gravitation and weightlessness as stated earlier by my colleague. Firstly, I would like to introduce gravitation to you. Gravitation is a science concept that has been known and understood right from Newton's time. It was he who propounded the law of gravitation from mathematical theory. Since that time, the theory has been used by other scientists in computing various constants and quantities that relate to objects on Earth in space. What do you think gravitation means? There is a force which pulls things thrown upward towards the earth. Imagine I pick a stone and throw it up. This stone tends to fall down back to the earth, and this is a result of force acting on the stone, and this force is called gravitation. The scientist who discovered the existence of this force is known as Isaac Newton. He said that the force of gravity or gravitational force exists between all bodies. Thus, any two masses which are separated by a distance have a force of attraction called gravitation existing between them. That is, for gravitation to occur, it has to be between two bodies, and when we talk about body, we can simply say a body is anything that has weight and can occupy space, and when we say a body has weight, this makes us know mass is concerned, and as far as mass is concerned, there is surely a force existing in it called gravitational force. This same gravitational force is the force which pulls us towards the earth. It is the same force that gives all objects their weight, and the weight of an object is the force with which the earth pulls the object. Now I will be moving on to explaining weightlessness. When an object moves around a circle at high speed, a force called centripetal force acts on it. This force is the one that makes a body moving with constant speed to remain in a circular motion. An example of centripetal force is orbiting of the Earth around the Sun, which is always in a constant speed and is always directed towards the center of the circle. The total gravitational force on a body is composed of two forces for an object moving in a circle. The first component is its weight. When this happens, the moving body experiences weightlessness. So briefly, we can say weightlessness is a condition that occurs in objects in fast circular motion when the centripetal force is equal to the weight of this object. In this condition, the two forces are equal and opposite, and this will lead us to our next topic, the Earth in space.
Good day everyone, I am Suleiman Muhammad Abba. By name, I will be describing the Earth in space. Earth, our home, is a world unlike any other. It is the only place in the universe that hosts life. The Earth is the fifth largest planet in the solar system with a radius of 3,959 miles, and it is the only one known to have liquid on its surface. It is unique in terms of monikers. Every other solar system was named for a but our world for at least 1,000 years by some culture has been described using Germanic word Earth, meaning the ground. Earth orbits the sun once every 365.25 days. Since our calendar year has only 365 days, hereby we added an extra leap day every 4 years to account for the differences. Although these differences cannot be felt, the Earth zooms, though it orbits at an average velocity of 18.5 miles a second. During this cycle, our planet is an average of 93 million miles away from the sun, which is equivalent to the distance that takes light about 8 minutes to traverse. Astronomers define this distance as one astronomical unit, which is a measure that serves as a handy cosmic yardstick. Earth rotates on its axis every 23.9 hours, which when approximated is 24 hours, defining day and night for space dwellers. This axis of rotation is tilted 23.4 degrees away from the plane of which Earth is orbit around the sun, giving us season. Whichever hemisphere is tilted closer to the sun experiences summer, while the hemisphere tilted away gets winter. That is, as the Earth rotates around the sun, the part of the Earth that is closer to the sun experiences hot season, and the part of the Earth that faces away experiences cold season. In the spring and fall, each hemisphere receives a similar amount of light on two specific dates each year, called the equinoxes. both hemispheres get illuminated equally, and this will lead us to our next topic, components of the solar energy.
Hello everyone, it's me again, Falula Giwa, and I'll be taking you on the identification of the component of the solar energy system. Firstly, we know solar energy is the energy that is gotten from the sunlight. There are four major components of the solar energy system. We have the panel, the inverter, the waking, and the solar battery. The panel are the most visible element of the solar energy system, and they are in essence called the phase. This solar panel has solar cells in them that stimulate electrons from the direct current electricity that is generated from the sunlight. Note, it is the sunlight itself that generates the electricity and not the heat. The inverter are a crucial part of the solar energy system. It works constantly and tends to be the most likely to have faults. Their purpose is to convert direct current electricity that the solar panel produces into 240 volt alternative current electricity, which powers everything in our home. The raking is the one that securely attaches your panel to your roof. And lastly, we have the solar battery. They are used to store energy during the day to be used throughout the night. All these, that is the panel, inverter, raking, and the solar battery, is what we put together that makes up the solar energy system. My next topic will be on rotation and revolution of the Earth and the Moon. Rotation and revolution of the Earth and the Moon. The Earth rotates on its axis relative around the Sun every 24 hours mean solar time, which represents an average of the variation caused by Earth's non-circular orbit. The Earth's rotation relative to fixed star is 3 minutes 56.55 seconds shorter than the mean solar day, which is equivalent of 1 solar day per year. Rotation and revolution of the Moon. The Moon orbits the Earth once every 23.322 days and approximately 27 days. For the Moon to rotate on its axis, the Moon does not seem to be spinning, but it appears to observer of the Earth that it keeps almost perfectly still. Scientists call the rotation of the Moon synchronous rotation. The Moon that is closer to the Earth is called the near side, and the opposite side is called the far side. Thank you for listening.